Hello and welcome to Coffee Coder. My name is Andrew, and today I will be talking about sets within the C++ standard template library. In this video, I will be explaining what exactly a set is and show you how to use one in C++. So let's get started. Sets are a type of associative container, meaning items within this container are referenced by a key rather than a position. A set is a container that contains a collection of unique elements. For example, let us pretend our set is a container of type fruit. Because our container is a set, each fruit we put in it will have to be unique. So if our container held an apple and an orange, we could add a banana, and since there is no banana already in the container, it will hold it. But if we tried to add another banana, it would recognize that there is already a banana and ignore the new one. Sets can be useful for storing values that you would want to quickly look up for comparison. For example, say we want to create a program that holds a giant database of names, and we want to detect if a person with a unique name is being added. We could use a set to check this. This would save a lot of computing time, as set's find function has a logarithmic time complexity of O log n, as opposed to searching through the entire list with a linear time complexity of O(n). Alternatively, there is an unordered set whose find function is much faster with a constant average time complexity of O(1). Now that we've gone over what exactly a set is and how it can be useful, let's head on over to our text editor and write some code in C++. Alright, here we have an empty C++ program. To add set to it, we would first need to include set. Then in our main function, to declare our set variable, we will type in the key term set, followed by the data type we want our set to contain. So we will use string in our case, and we will give it the name names, because we want to create a set that contains names. To add an item to our set, we will use the key term insert, followed by the string that we want to add to our set. So in our case, I'll add max. To check if an item is in our set, we can use the count function. What count will do is it will return 1 if it finds the item in our set, and 0 if it doesn't. So if I ran this function, we can see that, yes, max is in our set. If I change this, it will return 0. This number won't change even if you try to add another max, because just like I explained before, a set contains only unique values. So when we try to add max twice, it still will only print 1, not 2. Another way to check if an item is in our set, we can use the find function. What the find function will do is return an iterator to the item that contains the variable we're looking for. Since it is an iterator, we will need to compare it to something in order to check if it is in fact in our set. If an item is not found, it will return an iterator to the end of the set. So all we need to do is check if what is returned is not equal to the iterator at the end of our set. So we will type in names.end. .end returns an iterator to the end of our set. And we'll put this all in an if statement. And as we can see, Max was found. If we change this, Max will not be found. Since a set is an associative container, items within the set can't be referenced by location, so looping through the set is a bit different than looping through a vector or an array. To loop through our set, we will need to use iterators. So if we wanted to create a for loop, we would have to create an iterator that points to the beginning of our set. So to create an iterator, we would need to redefine our data types and then type in : iterator. We will give it a name, iter, and then set it equal to the beginning of our set. And then our end condition is if our iterator is equal to the end iterator. So we would type in iterator is not equal to names.end. And then because this is an iterator, we can use the ++ operator to increment it. And our iterator is pointing to the item within our set, so we will need to dereference it. Let me add some items to our set. So this should print out all the items within our set. Bob, John, Lily, and Max. Notice how Max isn't at the top. That's because our set has put them in alphabetical order. If we were to use an unordered set, the order would kind of be random. Another cool function you can use is the size function, which just returns the size of your set. And the clear function, which removes all items from your set. As we can see, our size was of size 4, and then when we use the clear function, it removed all the items, so our size became 0. Another useful function could be the empty function, which just checks to see if our set is empty. That is all for sets. I hope this video was helpful and that you learned something. If you want to know more about sets, check out the C++ reference on sets. I'll link it in the description. I hope you have a wonderful day, night, or whenever you are watching this.